Good morning. I hope you guys had a great spring break. I know it didn't seem like spring break, and I want to let you guys know I really miss you guys, and I actually look forward to making videos because I feel like at least I'm talking to you guys, so maybe you guys are listening. We are doing 2 lessons this week, 12.3 and 12.4. 12.3 is going to be modeling using quadratic functions. Quadratic function is anything with x squared, and modeling just means word problems. They're easy, don't worry. A couple things you might want to think about. Quadratic functions model many real life situations. St. Louis Arches. Not sure if you guys have been there, but I've been here, and you only get to about right here. You take this elevator. Oh, maybe it's not even that high. Pretty cool. McDonald Arches, which you guys might have been eating too much over spring break. Anytime we do a jump, throw a ball in the air, shoot off a rocket, anything like that. Parabolic shapes of a dish, so basically satellite dishes. Those are all examples of quadratics. Okay, so we're going to talk about some word problems and how you know a lot from the word problem. So a ball is thrown in the air vertically upward with initial speed of 96 feet per second. This is not important other than they had to use this to write this equation. Its height after t seconds, so t, instead of x and y, we're going to have t and h. T is going to represent time, and h is going to represent height. See? And this is the equation. H equals -16, parentheses t minus 5 squared plus 256. So we're throwing a ball up. It's going to come down, gravity. This, pretty interesting, that is the coefficient of gravity. So anytime you see word problems with that, it's coefficient of gravity. That's how things come down. So all we're going to do here is draw a sketch and label axis. Okay, so usually we draw an axis, we draw a big T, we have positive x's and positive y's. Here, and we have negative x's and negative y's. Here there are no negatives. You can't have negative time, and you can't have negative height. So we're just drawing quadrant 1. And we're going to make this time, because it's independent. And this is our height, because it's dependent. And our height is in feet. And when we throw up a ball in the air, usually it is not thrown from the ground. Only time you do that is if a rocket shot, but usually our hand is up high and we're throwing it, and whatever comes up comes back down. So that is just a sketch of what it would look like. Okay, so this is all on your notes. I guess I should have said this beforehand. I have attached a blank notes, so if you want to write on it, I've attached notes that are going to be filled out, and then videos. So my suggestion is for you guys to watch the video and make sure you understand, and then maybe go back and look at the filled out notes. You don't have to print anything, up to you. It's all there for you. Okay, so here's still the same equation. How high does the ball actually go? What's the maximum height? And how do you justify your answer using complete sentences? So I'm not good at using complete sentences, but I'll try. But how high does the ball go? Well, there's something, this is called vertex form. And if you guys remember, 5, 256 is our vertex. So how high does the ball go? Well, that would be our y value, which in the case is h, and it would be 256 feet. So the ball goes 256 feet, and it would happen after 5 seconds in the air. That's a long time. That's a pretty high throw and for a long time. So I'm going to go back to the graph for a second. That means that this point right here would be 5, and this would be 256. How high is the ball after 4 seconds? Well, we can use this equation. We're going to let t equal 4, and we're going to find h. Okay, order of operations, we're going to do parentheses first. That's going to be -1. -1 squared is 1. So we get the height equals negative 16 times 1 plus 256. So after 4 seconds, he would be 240 feet. So that's before it hit the max. So you throw it up in the air, 4 seconds, 250, 5 seconds, it's 256. And then it'd have to come down. It says use your sketch to identify the domain and range that makes sense for this problem. I've always told you guys in the other videos or other things I've showed you, domain's all reals, all reals, all reals. But not in this case. Our domain is our x values or our time. Time can't be negative. So our time has to be at the lowest 0. 0 seconds, I haven't thrown the ball yet. And the highest would be when it hits the ground. Whatever time that is. Maybe that's 10 seconds. Maybe it's 9, whatever it is. Our range is how high the ball is going. Well, the ball would go to 0 if it was at the ground. And the highest it's going to go is 256. We do know that. So that would be our range. So, graph's going to look like an upside down parabola. Negative makes it upside down. It is going to be narrower than usual, but it's hard to tell because the graph would be pretty big. The vertex gives you all the information about the time and the height, and then you can plug in other numbers to help you. Okay, next question. Okay, so that most of the time when we think about quadratics, we think about a ball going in the air, rocket being shot off, stuff like that. But it can work in business. Steve's Boats Incorporated has determined that the number of boats produced each day will yield a profit, and this profit means how much money they make. P of x is going to represent how much money, equals negative 15 x minus 6 squared plus 540, where x is the number of boats they produce each day and the px is the profit. Draw a sketch. Well, again, you can't produce negative boats, and hopefully your company's not going to go in the hole and make negative profits. So this is going to be the boats, and this is going to be our profit. And if we put 0 boats in there, probably going to make 0 money. But in this case, so we're going to say it goes like this. Still upside down. And where we're at it, the vertex would be this. So this point right here would be 6, 540. So that's the maximum boats they should produce to make the maximum profit. Okay, so a couple word questions, word problems I mean. How much profit is realized if you make 3 boats? So all we're going to do is plug in the number 3. Okay, order of operations, 3 minus 6 is negative 3. Negative 3 squared is 9. And negative 15 times 9, oh, yeah, sorry, times 9 is negative 35. 135 plus 540. So if they made only 3 boats, they would make $450. That's probably per boat, I would assume, not $450 for the whole thing. What if they made too many boats? What if they made 10 boats? And you'd think, oh, the more boats they made, the more money they're going to make. Well, if they make too many boats, I might have to hire more people. And so it may cost them more. So if we do this one, we make 10 boats. It's on the other side of the vertex, so it's going down. So like that's why we talked about increasing and decreasing the graph. So before 6, I mean, you're making more money. Then after 6, you're making less money. So now it's decreasing. So this would be 4 squared, which is 16. And if we calculate this, this now gives us $300. We didn't make as much money as we did if we only made 3 boats. How many boats should Steve produce to maximize daily profit? What is the maximum? Maximum profit is the Y value. That's the height. How much should he produce? He should produce 6 boats, because that was our vertex, and the maximum profit he would get would be $540. Super easy. Okay, so on the next page of the notes, there's another example, and this is a solar heating company. Again, it's some business, and it produces 10 solar water heaters per day. If they were to increase the production, income from the sales would increase, but so would their expenses. If they were to decrease their production, both their income and their expenses would decrease. Since they want to maximize their profit, they've asked a business analyst to determine the function. The analyst estimated that the profit Y in thousands, so this is in thousands, so every time if you get the answer is 5, that means 5,000. And X is how much they produce. We're going to draw a sketch. So if they make 0 boats, they're going to get 0 profit. So this is, I'm not boats, sorry, this is solar water heaters. So this is water heaters. This is their profit again. And here, this would be 14, and this would be 196,000. So you put 3 zeros, so 196,000. How many boats did they produce to maximize the profit? Well, your vertex, 14 boats. What would their maximum profit be? 196,000. Be careful because it's in thousands. Okay, now we want to say our domain and range. Again, this was what the graph looked like. In this case, if I actually put a 0 in here, 14 squared is 196. So if you have 0, you get 0. So our domain would go from 0 to whatever it is would hit the maximum. I don't know what this is going to be right now, but we are just would say the maximum that they could actually produce. We'll learn how to solve that later. And the range, 0 money, all the way to the maximum they could earn, which is 196. This is known by. And so, gives you an idea of the word problems that you guys will see on the homework. If you guys have any questions, let me know. The homework is pretty much the same. It's going to ask you some profits, going to ask you to draw some sketches, try to be as accurate as you can, and I will post another video for 12.4. All we're doing is 12.3 and 12.4, and it is listed on Google Classroom. Have a great day. Bye.